At high altitudes, most of the dust in the atmosphere comes from space, rather than the Earth. Thousands of tons of interplanetary dust particles, or IDPs, enter the atmosphere each year. Much of the dust is thought to come from comets, which contain primitive, unaltered matter from the formation of the solar system. A team of scientists, including researchers from the Carnegie Institution, have for the first time tied upper atmosphere dust to a particular comet. In April 2003, a NASA aircraft gathered dust samples after the Earth passed through the dust tail of Comet Griggs-Skellerup.
We got our hands on some of these IDPs that were collected in April 2003, and what we found when we studied them by a large number of techniques is that they're very different from typical IDPs that are found in that they are what we would say is more primitive. They have higher abundances of material that formed before the formation of the solar system. As a result, we believe that since these particles were collected at a specific time and share some very interesting properties that are not typical of IDPs, we believe this ties them to the comet we were hoping to study, Griggs-Skellerup. And in this way, it allows us to compare on a microscopic scale in the laboratory dust particles from different kinds of comets and use that as a tracer of different processes that occurred in the solar system 4.5 billion years ago.
This interplanetary dust can be compared to the samples returned by NASA's Stardust mission that returned comet dust in 2006.
This is very important because although we've known IDPs come from comets, we've never been able to definitively tie a single IDP to a single comet. And the only known cometary samples we've studied in the laboratory are those that were returned from Comet Wild-2 by the Stardust mission.
The samples provided a number of surprises.
The biggest surprise is the abundance of so-called pre-solar grains. And pre-solar grains are tiny dust particles that formed in previous generations of stars and in supernova explosions before the formation of the solar system, and were trapped in our solar system as it was forming and are found today in meteorites and in IDPs. And they're identified by having extremely unusual isotopic compositions compared to anything else in the solar system. And one important thing about pre-solar grains is that they're generally in very, very low abundance. In these IDPs that are associated with Comet Griggs-Skellerup, they're up to hundreds of times higher abundances than we've seen in other primitive materials, which means that for some reason these grains have either trapped a higher abundance of them in the very, very earliest stages of solar system formation, or these samples have destroyed grains. These samples seem to be much more primitive, much less processed than the samples from Wild-2, which seems to indicate that there's a huge diversity in the degree of processing of materials in different comets.
The unusual ratio of rare isotopes gives some indication of when the samples were formed.
There's various chemical reactions that can cause these fractionations, but it most likely happened before the formation of the solar system while the material was in a molecular cloud in the galaxy.
The research was reported online in Earth and Planetary Science Letters. This is John Strom for the Carnegie Institution.